Hey guys, so today I'm going to be building an outlet saver, or at least that's what I'm calling this. All this is a relay controlled outlet. Aquarium Engineering makes these and Digital Aquatics used to. And there are a whole bunch of reasons why you should be using one of these. For starters, you can save your energy bar. An energy bar is a lot more expensive than a single relay. And these relays that are in these energy bars do wear out, especially if you're using them to switch higher loads. Second, you can take load off an outlet or a circuit. If you're using an Apex, then the energy bar EB832s, the newer energy bar outlets, have a max of 7 amps or 700 watts, and 15 amps or 1500 watts for the whole bar. The old EB8s are 5 amps for these outlets over here, and 10 watts for these mechanically controlled outlets over here, and 15 amps for the entire bar. So you should probably be using one of these if you use a larger heater, a chiller, or maybe halide lights. And then you have the circuit or wiring of your house, and that probably has either a 15 or 20 amp max, and that's decided not just by the breaker, but the wiring and the outlets that compose that circuit. So you may want to have your energy bar on one circuit and some of the things that it controls on a separate circuit in order to reduce the demand on any one circuit. You can also get an extra 2 outlets out of your energy bar 832 if you're not using the two 24 volt accessory ports. Now, I use those two 24 volt outlets for other things, so I'm probably just going to continue using a 120 volt outlet. But if you don't use those, really you have an EB10. So to build our outlet saver, we're going to need a relay. And all a relay is a switch that you control with electricity. When you apply a voltage to a coil, it opens that switch. Now, I can actually show that to you with this see-through relay I've got here, which is rated for 12 volts, and this 9 volt battery. So if we zoom you in to this see-through relay, we can actually see the coil right there, and that's what we're energizing with the signal. And then this bar right here is a switch, and that connects to all these contacts right here. So if we connect up this 9 volt battery, you can hear it working, and you can see that switch moving back and forth, and it's just opening and closing those contacts. Now, relays come in a lot of different variations. I've got a whole bin of relays right here, and you need to pick the right one depending on what you want to do with it. So relays come in a lot of different types, but the most important parts are the coil voltage, which is the voltage required to energize that coil, and whether the relay is normally open, so that energy can't get through the relay, or normally closed, so that energy can get through the relay when the power is not applied. Typically, we're going to want a normally open relay. So finding the right relay can be a little bit daunting, but I'm just going to suggest a do-it-all relay. And luckily, this is one of the cheaper options anyway. So this is an RIB 2401B power relay, and it currently sells on Amazon for $17, and it comes already in a box. So these relays have a 24 volt coil or a 120 volt coil, which means we can use it with either the 24 volt accessory outlet on an EB832 or a 120 volt outlet to control it. So this relay is rated for resistive loads of up to 277 volts at 20 amps. And that would be like a heater. So you could run a 2000 watt heater on this relay. It also says it's rated for 10 amps at 120 volts. That's tungsten, that's a light bulb, so we don't really need to worry about that because even metal halides, they don't have a filament, so there's no inrush current, so don't worry about that. You can exceed that for almost everything we do. And then it has a 1 horsepower rating at 120 volts, So that's anything with a motor. So a pump or a chiller would count as 1 horsepower. And you can go up to 2 horsepower if you have, say, a really large chiller and it runs on 220 volts. Now you can buy relays with larger contact ratings than this, but this is a pretty beefy relay. And you'd have to go with a different brand. It wouldn't come in the nice case and all that. You'd have to put your own case together. But this is going to cover almost anything that you can throw at it as an aquarist. So we're also going to need an outlet. I'm going to be using this heavy-duty 20 amp GFCI outlet, and it's rated for 20 amps, which is exactly what our relay is rated for. Then we're also going to need a weatherproof box, preferably with the 1/2-inch threaded connections. And we need a liquid-tight 1/2-inch NPT cord connector. Now, I actually don't have a cord connector that's going to work right now. This one isn't large enough. There's actually a brand called Liquid-Tight that makes good ones, but I'm out of them. And I'm not about to go out right now just to get a cord connector. So instead, I'm going to be using a zip tie as strain relief. Then we need a power cord for the outlet. Now, you could directly wire this with Romex or armored cable as well. You just need to make sure that the cord that you used is rated for the amps that you're going to be drawing. To match the relay that we're using and actually be able to use it at 20 amps, you need a 12 gauge cord. That's a pretty big cord, but also all the other parts of the circuit need to be rated for 20 amps. Now right here I have a 16 gauge cord, which is only good to 10 amps. So if I need any more load, then I need to change out the cord. But I know I'm just going to use this for my chiller, and 10 amps is plenty for that. Then lastly, we need a signal cord. This can either be a 120 volt cord, and this can be really light duty, it's not going to draw any amps basically, or it can be the Apex 24 volt accessory cord, depending on which one that you want to use. Alright, so the first step is to take your waterproof box, knock out 2 of the holes, and screw your relay onto it. Then we need to insert the 2 cords, both the relay and the power, into the waterproof box as well. Alright, so we're going to deal with the signal side of the relay first. So take your signal cable and connect the positive, or the hot side, to the correct cable, which if you're using this relay, that's going to be the black and white cable. So we're just going to take those 2 and put a wire nut on them and twist until it becomes hard. Alright, and then take your neutral wire and we're going to attach that to the communication wire, which is yellow and white. And by communication wire I meant common wire. Alright, then shove those inside the box. And we're going to want to cap the last wire. If you did this correctly, this should never have power, but we're just going to cap it anyway and throw it in the box. Don't worry too much about the wiring order on these, so it shouldn't really matter what order you have those on. Alright, now we need to deal with the power side of the outlet. So grab your outlet, and so the first steps are the same as wiring up any outlet. We are going to connect the neutral, which is the white, and the ground, which is the green in this case, although you probably want to double check that with your multimeter. You're going to connect those into the neutral and the ground on your outlet. So the neutral should say white and the ground will be green. Alright, make sure those are nice and tight, and then we have to wire the hot wire. And this is where the relay comes into play. So this relay comes with normally closed and normally open contact wires. And for most things, we want it normally open, or the outlet to fall back to off. So we're going to take the normally closed wire and cap it off. And in this relay, the normally closed wire is the blue wire. So I'm going to cut that shorter and cap it off. So then we have to decide whether we want to connect this hot wire to the common or the normally open contact. Now, I'm of the opinion that connecting it to the normally open contact is safer, as then the normally closed contact is never live, even though we did cap it off. So I'm going to wire it like that. So the normally open contact is orange and the common wire is yellow. So I'm going to strip back the orange wire, and then I'm going to connect it to the hot or black wire from the cord. Then connect the common wire to the hot side of the outlet. And if you couldn't get that strain relief because of COVID-19, then don't forget your zip tie around the wires as strain relief, because you don't want these being pulled on. Alright, now comes the hard part, shoving it all into place and actually getting the outlet on.
A little longer than a few minutes later.
So once you've got it all wrangled into place, put your cover plate on. I cut my own out of kind of a standard plate because I couldn't find a GFCI outlet cover without the flap that has the 4 screws, so I just cut out my own. So that's it for the outlet saver. You just plug your power cord into whatever outlet you're using and your signal cord into your apex. And then you can plug whatever you need to power into your outlet. And if I go to turn on my chiller in my apex, it turns on. And when I turn it off, it turns off. So that's it for the outlet saver. If you have any comments or suggestions, please put them in the comments down below. And as always, guys, thanks for watching.